Okay, guys. So whenever we start taking notes, I want you to title the top of your page. We're just going to put notes, and then we're going to put today's date. So these are our notes for August 12th, 2019. Okay? And we're going to start off with some vocabulary. Now remember, these vocabulary words that you're seeing now will be on your first unit test in about 2 weeks. I'm going to send you out a link to Quizlet a little bit later so you can start studying those. And they're all words that you're familiar with, but we want to make sure we're using them when we're talking about multiplication and division and all that good stuff. Okay? So the first one for vocab, we'll go ahead and put a vocabulary title right here so you know this is vocabulary. Alright, and your first word is going to be sum. Someone tell me in your own words what you think the definition of sum is. What you think? Absolutely. Now I'm going to change the words just a little bit. Did everybody hear what he said? Answer to an addition problem? I'm going to change it just a little bit. We're going to say the result, which we know the result, of course, is the answer. The result of adding 2 or more terms. 2 or more terms. Now we're using the word terms instead of numbers because when we get to algebra, we're going to be referring to terms. So we want to get used to seeing that. So sum is the result of adding 2 or more terms. We can add more than 2 numbers at a time. Yeah. Make sure I close the door. So we get here. Okay. Our next word is going to be difference. What do we think the definition of difference is? Anyone? What do you think? Go ahead. You got it. The result or the answer of subtracting. Now, can we subtract more than 2 things at once? Not really, because we're really technically adding 2 numbers together and subtracting. If we're doing 3, yeah. So we're going to say the result of subtracting 2 terms. Because it's just 2 terms, it's not 2 or more. So that takes care of addition and subtraction. What do you think we're going to next?
Multiplication.
You got it. So anybody want to take a guess what our next vocabulary word is, Sully? Product. What is a product? Anybody? You don't have to raise your hand. Just tell me. What's product?
The answer is multiplication.
You got it. So product we're going to say is the result, which we also know means answer, of multiplying 2 or more, because we can multiply more than 2 at a time. Okay, 2 or more terms. Now, we're not going to get into division today. We'll start talking about division tomorrow. We're going to focus on multiplication today. So if we have the product, what's the other part of a multiplication problem? What are the first 2 numbers? You got it. Factors. I had a student, she's in 12th grade this year. When I taught her in 5th grade, she came up with the neatest saying, and I've used it ever since. She said, factors are like a factory. They make a product. What does a tennis shoe factory make? Tennis shoes, okay? That's their product. All right? A cereal factory makes cereal. That's their product. So when we're talking about multiplication, our factors, our numbers, they make their product. Okay? So our last vocabulary word is factor. And factors are 2 or more terms being multiplied. Now, factor actually has like a little second definition. If you have the factors of 7, what are my factors of 7? Anybody?
14.
Careful, because those are multiples. Think the opposite direction. 1 and 7. So 1 and 7 are my only factors of 7. So that means what numbers can 7 be evenly divided by without having any leftovers? 1 and 7. So the other half of being a factor is that it evenly divides a larger number. For a number to be a factor, let's say we have the number 6. Is 4 a factor of 6? No. Can I evenly divide 6 by 4? No. So it can't be a factor. It has to evenly divide that number without having any leftovers or any remainder. Give you guys a chance to copy those down. Everybody good so far? Okay. Am I going too fast? All right, just making sure. Okay, so this Friday, you're going to have a little quiz, other than your multiplication facts, but it's going to be on addition, subtraction, multiplication, and division. Now, how many of you used different strategies last year for multiplication? Anybody use lattice? Thank goodness. Okay, good. I'm glad you don't know what it is. Anybody use the array or the windows? Okay. My job this year is to get you to use the traditional algorithm. Our objective is that it's the fastest and the least opportunity for errors. Okay? That word algorithm sounds kind of fancy, but it's not. It's a fancy word for something very simple. How many of you use shampoo? Everybody, right? Okay. When you look at the back of your shampoo bottle, what does it say?
I don't know.
Wash, rinse, repeat. Okay? Wash, rinse, repeat. 3 steps, right? That's an algorithm. An algorithm is a step-by-step process to achieve a desired result. Well, your goal there is to wash your hair. So you wash, rinse, repeat. That's your algorithm for shampooing your hair. For multiplication, we have what we call our traditional algorithm. You see the learning target behind me? That is my goal for you, is that you will multiply using the traditional algorithm. And we're going to go through and do an example together. All right, so we've kind of finished our vocab. I'm going to kind of divide my notes up here. This is the vocabulary that will go with our multiplication. So I'm going to come down here in big letters, or however you want to do it. And we are starting multiplication. Now, we're going to do a really big problem together. And then you're going to do some practice in just a minute on your own. But I'm doing a really big one, a really, not difficult, but a little bit more difficult than what's on your homework, so that way you have something to look back at, and what you're doing home tonight hopefully won't seem as difficult as what we're about to do. All right, so we're going to look here. We've got 10,127 times 868. It's a big one. Now, when I start multiplying, am I going to start over here with this 8? No. Where am I going to start?
With the other 8.
Where is that 8?
The one column.
You got it. So we're always going to start, and we'll put myself a note over here, start in ones place. We always want to start in the ones place. These numbers on the bottom, they're super friendly. They want to meet every person upstairs. So you can't multiply just one number by 1. You have to multiply each number by every number that lives upstairs. Alright, so y'all help walk me through it. What's 8 times 7?
36.
Got it. We're going to carry our 5. 8 times 2?
16.
Plus 5 would give us
21.
not quite 21. Yeah, almost. Okay, carry my 2. 8 times 1?
8.
Plus 2?
10.
Awesome. 8 times 0?
0.
Plus 1? 1. And 8 times 1?
8.
Am I done?
No.
No. But the thing is, I do. But I'm not just adding a 0. You know the 0 has another name. Anybody know it?
A placeholder.
You got it. It's a placeholder. So I'm done multiplying in my ones place. So I'm going to put a placeholder right here that shows that I've moved on to my tens place. Whenever you're multiplying, the number that you're starting with here should be where your number starts here. It should line up directly below it. Okay? Now we start all over again. 6 times 7.
42.
42. Here are 4. 6 times 2.
12.
Plus 4. 16. Alright. And 6 times 1? 6 plus 1 is,
7.
got it. And then 6 times 0? And 6 times 1? 6. Okay. Now am I done?
No.
How many placeholders now?
2.
2. Because now I've moved from my 1s and my 10s, now I'm in my 100s, and it will line up right below my 100s place. 8 times 7? You ever heard the little rhyme 5, 6, 7, 8, 56 is 7 times 8?
Yeah.
You ever noticed that?
Yeah.
8 times 7 was always a hard one for me, but if you think about this,
Yeah, it's so
it goes in order. It's 5, 6, 7, 8, 56 is 7 times 8. Mm-hmm.
Now 6 times 6 is 6.
Yep, sure is. Yes.
You can also write the same numbers like this.
You absolutely can. Does everybody see this? We're now multiplying by the same number. Is there anything wrong with, now that I put my placeholders, coming up here and putting 6, 1, 0, 1, 8? Does that work?
Yeah.
Sure does. Now, I've got to add them together, right? Okay, what is 6 plus 0 plus 0?
6.
1 plus 2?
3.
6 plus 6?
12.
Carry my 1. 7, 8, 9, that gives us 10. 8 plus 1 is 9. 6 plus 1 is
7.
and 8. Now, we're going to add commas just to help it make it easier for us to read. We do have a large number, but guys, this is the thing. Do you see how we followed that process over and over and over? Okay, that's all an algorithm is. It's a step-by-step process to achieve a desired result.
Yep.
Any questions so far? Okay, we're going to do a little bit of practice on our own. You'll have some time. What you don't finish in class will be for homework.